For most of our lives, the idea of quantum computing has been a ghost in the machine of our imagination. It was the stuff of science fiction, the fantastical technology powering spaceships in movies, or the wild theories whispered in the halls of physics departments. It was a beautiful, tantalizing dream, something permanently trapped in the amber of complex equations and isolated, experimental labs. It felt like a promise for our grandchildren's world, not our own. Well, that illusion just shattered. The dream is over because we have woken up to a new reality. In a lab chilled to temperatures colder than deep space, a machine named Willow has done more than just run a test. It has dragged the raw, untamed power of the quantum realm kicking and screaming into our world. This isn't just another step forward in technology. This is the sound of a door being kicked open, and on the other side is a dawn of a radically different era. What was once theory has become tangible hardware, and it signals a fundamental shift in the story of human innovation. The future didn't just knock, it broke down the door. To understand how monumental this is, we have to honor the giant on whose shoulders we now stand. For the better part of a century, classical computers have been the architects of our modern world. They are the silent engines behind every skyscraper, every life-saving drug, every global connection. Their language is simple, elegant, and powerful. The bit, a 1 or a 0, a switch that is either on or off. This binary logic, this world of absolute yes or no, powered the greatest revolution in history. We followed Moore's law like a sacred text, shrinking transistors to the size of atoms, packing more and more power into smaller and smaller spaces. From room-sized behemoths to the supercomputers in our pockets, these machines have done everything we asked of them. But we were about to ask for the impossible. We started asking questions that couldn't be answered with a simple yes or no. We brought our machines to the edge of nature's deepest, most chaotic complexity, and for the first time, they hit a wall, a hard wall. There are problems in our universe so complex, with so many interacting variables, that even the fastest supercomputer on Earth would take longer than the age of the universe to solve them. We had built the perfect tool for a black and white world, only to discover that reality is painted in an infinite spectrum of quantum color. Here is the fundamental disconnect we've been struggling with. Nature doesn't think in ones and zeros. It doesn't operate on a binary system. Think about the intricate dance of a protein folding into its perfect shape to fight a disease, or the chaotic, beautiful explosion of a distant supernova, or the simple miracle of photosynthesis turning sunlight into life. These are not on-off processes. They are symphonies of possibility, governed by the strange and wonderful rules of quantum mechanics. Trying to simulate this reality with our classical machines is like trying to capture the entirety of Beethoven's Ninth Symphony using only a single drum beat. You can get the rhythm, perhaps, but you lose the melody, the harmony, the emotion. You lose the soul of the music. To truly understand, to model, to predict, and ultimately to engineer reality at its most fundamental level, we needed more than a faster calculator. We needed a new computational language. We needed a machine that thinks the way nature behaves. For decades, this new language, quantum computing, remained a theoretical one. It hovered just beyond our grasp, a shimmering possibility hampered by two brutal enemies, fragility and noise. Quantum states are unbelievably delicate. The slightest vibration, a stray magnetic field, even a tiny change in temperature could cause the whole system to collapse, a phenomenon called decoherence. It was like trying to build a sandcastle in the middle of a hurricane. We could build small, experimental quantum processors with a handful of quantum bits, or qubits, but they were mostly scientific curiosities. They could perform a few tricks, but they couldn't solve a real problem. They were too unstable, too prone to errors. They were fascinating experiments, but they couldn't truly compete with the raw, reliable power of a classical computer. Until now. With Willow, Google has crossed the threshold. This isn't just an experiment anymore. This is a functioning quantum processor that doesn't just perform a task, it competes. It has stepped out of the pristine quiet of the laboratory and onto the world stage, ready for a showdown. So what is this machine, this harbinger of a new age? Its name is Willow. And it isn't an incremental improvement. It's not the next iPhone, with a slightly better camera. It's a transformative leap, a different kind of being entirely. Imagine a device forged at the intersection of extreme engineering and fundamental physics. It's built from superconducting circuits, materials that, When cooled to near absolute zero, just a hair's breadth above the coldest temperature possible in the universe, allow electricity to flow without any resistance. At this impossible cold, the bizarre rules of quantum mechanics take over. Willow's core operates in a state of existence where the familiar laws of our world melt away. This machine merges the most advanced materials science and engineering with the deepest, most counterintuitive principles of reality. The result is a processor that can unlock computational states that have never, ever before been achieved in a physical piece of hardware. It's a machine built to harness the ghosts of probability. To grasp what makes Willow so powerful, you have to understand the heart of its magic, the qubit. A classical bit is a light switch. It is either on or it is off. It's a 1 or a 0. Its state is certain and singular. A qubit, however, is more like a spinning coin. While it's in the air spinning, it's not heads and it's not tails. In a way, it's both at the same time. This is a quantum principle called superposition. A qubit can hold the value of 1, 0, or a blend of both simultaneously. Now, that might not sound like much for a single qubit, but the power is exponential. 2 qubits can hold 4 possible states at once. 3 qubits can hold 8, 4 can hold 16. By the time you get to just 300 qubits, you can represent more states than there are atoms in the known universe. This is where the mind-boggling power comes from. Willow doesn't just explore one path to a solution like a classical computer. It explores millions, even billions of possibilities simultaneously. Its capability doesn't just add up. It compounds exponentially, creating a computational space so vast it dwarfs the combined power of every classical computer on the planet. Building such a machine is, frankly, an act of Promethean audacity. To make qubits work, you have to create one of the most controlled environments in the universe. Willow runs on materials so pure they have been engineered to near atomic perfection. It is housed in a series of nested refrigerators, each one colder than the last, creating a chamber that is hundreds of times colder than interstellar space. This extreme cold is necessary to slow down the universe, to quiet the atomic vibrations and thermal energy that would otherwise destroy the fragile quantum states of the qubits. This environment creates a pocket of extreme isolation, shielding the qubits from the chaotic disturbances of our world. Inside this sanctuary, operations can happen at breakneck speeds with a level of precision that is almost unbelievable. This combination of speed and precision is the holy grail for quantum machines. For years, it was a rarity, something you might achieve for a fleeting microsecond. Willow achieves it consistently. It is a masterpiece of engineering, operating at the very edge of what is physically possible. Despite these engineering marvels, for years the entire field of quantum computing was stuck in a devastating paradox. The ultimate enemy, the monster that devoured progress, was error and decoherence. The quantum world is inherently probabilistic and noisy. The more qubits you added to a processor, the more complex and interconnected it became. And with that complexity came more opportunities for things to go wrong. More pathways for noise to creep in. More chances for the delicate quantum states to collapse. And here's the truly revolutionary part. As they increased the size of these groupings, the error rate didn't go up. It went down. This wasn't the first time a quantum computer had claimed supremacy, but past demonstrations had faced valid criticism. This time was different. Google knew they had to deliver more than just a party trick. The benchmark Willow solved wasn't a contrived stunt. In essence, they used Willow's qubits to simulate the behavior of a complex physical system. Imagine tossing a handful of pebbles into a perfectly still pond and watching the intricate ripples expand and interact. By analyzing the tiny imperfections in that echo, they could measure the physical behavior of the system with a precision that classical hardware simply cannot simulate at speed. And here is the final crucial piece of the puzzle. The results it calculated about molecular behavior didn't just match the data that traditional chemistry labs collect. In some cases, it enhanced it. It revealed new layers of understanding in chemical structures that were previously invisible. This was the first time a quantum computer didn't just perform a calculation faster. It contributed new knowledge. It saw something that we couldn't see before. It didn't just outperform our old tools. It became a new kind of scientific instrument, a microscope for looking at the fundamental building blocks of reality. For the first time, a quantum computer had not only won the race, it had discovered a new continent. So what does this mean for our lives, for our future? With tools like Willow, we are standing at the dawn of a new era. The era of designed materials. For all of human history, our process of discovery has been largely based on trial and error. We mix things together and see what happens. We test thousands of compounds to find one that works as a medicine. That is about to change. Fields like medicine, energy, and chemistry are about to shift from a game of chance to an act of precision engineering. Imagine being able to design a drug, atom by atom, that perfectly targets a cancer cell and leaves healthy cells untouched. Imagine crafting a catalyst that can pull carbon out of the atmosphere with perfect efficiency, or a material that can conduct electricity with zero loss at room temperature, revolutionizing our energy grid. We are moving from discovering materials to designing them. We are gaining the ability to build our world from the atom up. The story gets even more exciting when you consider the other technological giant of our time, artificial intelligence. In a beautiful symbiotic loop, AI was instrumental in helping to design the quantum chips and control systems that made Willow possible. Now it's time for quantum to return the favor. Soon, quantum computers will amplify AI in ways we are just beginning to imagine. Think about the hardest problems for AI today: optimization and logistics. How do you route every package for a global delivery company in the most efficient way? How do you design a city's traffic flow to have zero congestion? How do you model a global financial system? These are problems with an astronomical number of variables that choke even the most powerful classical computers. For a quantum computer, these complex systems could be solved fluidly, almost intuitively. We may soon see entire industries and even cities operating with a level of enhanced intelligence that is guided by a quantum core. It's important to remember that as breathtaking as these milestones are, they represent the beginning of a journey, not the end. Willow is the Kitty Hawk flight of the quantum age. It has proven that powered flight is possible. Now the work begins to build the jumbo jets. Google's roadmap is clear: They are on a trajectory toward million-qubit, fault-tolerant machines. What once sounded like speculative fantasy now looks like a clear engineering path. We are at the threshold, not the finish line. There are still immense challenges to overcome, but the fundamental questions of if have been replaced by the practical questions of when. We are living through the first few seconds of a computational revolution, and the pace is only going to accelerate. This chapter of human history that we are living through is only the opening act. The breakthroughs of tomorrow will outpace the wildest imaginations of today. This isn't just a story about a new computer. It's a story about a new way for humanity to see, understand, and shape its own reality. Watching this space isn't like following tech news. It's like watching the future unfold in real time, right before our very eyes. So what's the lesson in all of this for us, in our daily lives? I think it's a powerful reminder that the limits we perceive are often temporary. The problems that seem unsolvable today might just be waiting for a new language, a new way of thinking. For centuries, we spoke in the prose of ones and zeros, and it took us to the moon. Now, we are learning to speak in the poetry of quantum mechanics, and it could take us to the stars. The advice from this story is to cultivate a sense of wonder, to stay curious, and to never believe that we've reached the final frontier of what's possible. This breakthrough teaches us that sometimes to solve an impossible problem, you can't just build a better version of the old tool. You have to invent a new one entirely. How can we apply that to our own challenges? Where in our lives are we trying to solve a quantum problem with classical thinking? I'd love to hear your thoughts on this. What industry do you think will be the very first to be completely transformed by this technology? What does a future powered by quantum computing look like to you? Let me know your ideas in the comments below. Thank you so much for joining me on this incredible journey to the edge of physics and back. I hope you're feeling as inspired as I am. And if you enjoyed this glimpse into the future, don't forget to like this video. And be sure to subscribe to the channel so you don't miss the next chapter in our unfolding story.